Hi everybody. Today we're going to go over our Spongebob Variables activity. A couple of things to remember when you're doing variables. So let's do a little bit of review of vocabulary. You have the control group, which is the group that gets no changes to it. So if you're doing plants and studying the light that the plants get, those would be the plants that just sit normally in one place versus the plants you're going to sit in the windowsill or the closet. So you have the control group. So they get none of the changes. If you're doing plants, you want to control for as many things as you want. So you would want all your plants to have the same size of pot, the same soil, the same amount of water, same kind of nutrients in the pot, the same type of plant. So anything that could be different that you can keep the same, you're going to want to control for. The next is the experimental group, and that's the group that gets the change. And so in the plant example, those are the plants that are going to be going in the closet, in the windowsill, under fluorescent lights, that sort of thing. Other vocabulary words that we're going to be using are independent and dependent variables. The independent variable is the one that you change, the one that you're going to be manipulating. I spelled that wrong. So in our plant example, we were changing what kind of light the plant got. So the independent variable is what you change or manipulate. The dependent variable, is what you're looking for to happen. Did the plants grow better? The same? Did they actually grow less? So the dependent variable is what you're going to measure. What are you expecting to see? If I change the independent variable, what's going to happen? And so what you're looking for is the dependent variable. So when you're doing questions about this, and there will be several questions on independent, dependent, control, and experimental on your test, is to remember C for change equals I. So what I change is the independent variable. And what I measure, M, is the dependent variable. So if you can kind of remember this little grid, it'll help you in figuring out what things are dependent and what things are independent. So C equals I. The change you make is the independent variable. And then M equals D. What you're measuring or what you're looking for is the dependent variable. So if we look at Paddy Power, which is our first Spongebob variable to look at, we want to ask ourselves the questions, what am I changing? That's going to be my independent variable. And what am I measuring? That's going to be my dependent variable. So we read through our scenario, and then you're going to be looking for what is changed and what is being measured. Your first question deals with control group and experimental group. And so you're going to be looking for who got the sauce and who didn't get the sauce. So what did we change? We changed the sauce. So that's our independent variable. And what did we look for? We looked for if that reduced the amount of body gas that they were giving off. So what did we measure? That's the dependent variable. So the people in SpongeBob's friends group that got the new sauce, we want to see if eating that new sauce caused them to have less gas problems. So the gas problems are what we're measuring, and so that would be our dependent variable. Group B is our control group because they did not get the new sauce. They just got regular sauce. So the hardest part on these problems is determining what is the independent variable and what's the dependent variable. The next scenario has to do with slimatosis. In that SpongeBob notices that Patrick ends up getting yucky slime on his shell and it starts to stink really bad. And so one of their friends tell him that if you rub seaweed, it should help. And another one tells them that if you drink Dr. Kelp, it will help. So SpongeBob decides to test this. His things that he's going to change is rubbing seaweed and drinking Dr. Kelp. The things that you're going to remember that what you change is your independent variable. And what you're looking for is your dependent variable. So in this scenario, we're looking for whether or not Gary's shell has less slime and smells better. And so Gary rubs seaweed, drinks Dr. Kelp, and it turns out that the slime is gone and Gary's shell does smell better. But the problem with this scenario is that it's not a valid experiment. We don't know whether it was the rubbing the seaweed on his shell that made the difference or whether it was drinking the Dr. Kelp. So try to keep that in mind, that when you're doing experiments, to be valid, only one variable needs to be measured or tested. So only one independent variable. So in this experiment, they don't know which one caused the change. So it's not a valid test. The next scenario, you have your guys going to the gym, and Larry gets told that there's a new muscle cream that will double your muscles. And so they decide to test this. Sorry that my dog barked. And so he talks to Patrick and SpongeBob, and they agree to be part of his experiment. The control group is going to be SpongeBob, because when they work out, he's just going to put on normal lotion. So he's not getting the change. He's not going to get the independent variable. So when we look at our questions, what are we changing? What's our independent variable? That's going to be rubbing the special muscle cream. And then what are we wanting to measure? That's going to be our dependent variable. And that's going to be if we see an increase in muscles. Now we expect that nothing's going to happen but normal muscle growth for SpongeBob. And that Patrick is going to double his muscle power in the time frame that they work out. And I think here it says that it's 2 weeks. So the independent is the muscle cream. The dependent is whether or not Patrick has more muscles than SpongeBob, more muscle growth. Whoops, sorry. And you can see by the table, you can make some conclusions by the measurements that you took. And so Patrick increased by 5, and SpongeBob increased by 12. And so if we made a hypothesis when we started this, our hypothesis would have said that rubbing the special muscle cream on your muscles will double your muscle mass. And our experiments don't show that result. Our experiments show that SpongeBob doubled his results, but Patrick didn't. So we need to increase our sampling size. Maybe SpongeBob ate a whole bunch of amino acids and protein during the 2 weeks and Patrick didn't. So we go back to our experimental design and try to, 1, increase the number of people that are involved, and 2, try to control for variables that we didn't control in the beginning experiment, like diet. The next one is Microwave Miracle. It's our last one. And so Patrick is going to microwave fish food, and he believes that fish that get fed the microwave special fish food will swim faster through the maze, meaning that they're smarter. So he microwaves the food, and then he has groups of 10 fish. One group he feeds them special food, and one group gets just regular fish food. And so you should ask yourself questions in scenarios like this. What am I going to change? So what's my independent variable? And that's going to be the new special food, the microwaved, the zip-zappity food. And what's going to be the thing I measure, which is going to be our dependent variable. And that's going to be whether the fish swim faster through the maze, which they'll make an inference that the fish are smarter. And then which group is the control group and which group is the experimental group? That's another thing that you need to look at when you're looking at these scenarios. Again, these questions are going to be on your test, and there's several of them. So being able to tell these things apart are going to be very important. So if we look at the data, so we have our hypothesis, we know what our independent variable is, it's the special fish food. We know what we're wanting to measure, which is whether the fish swim faster in the maze. That's going to be our dependent variable. And now we need to look at our data and see what our conclusions are going to be. And so if we look at the data in the chart, we'll notice that it was about equal, that the regular fish compared to the special food group swam about the same. So neither group made it through the maze in enough difference that we could say that the fish food made a difference. And again, we're going to go back to our experimental design after we've done our initial experiment. Maybe we used 2 different types of fish. Maybe we used a minnow and a shark. Well, that's definitely going to make a difference. Or maybe we used a minnow and a guppy. So we're going to go back to our experimental design and look and see what we can improve on so that we can see the difference, because we really believe that microwaving the fish food makes a difference. We also are going to want to do more than just 10 fish. If you did 10,000 fish in each group instead of 10 fish, your results are going to be more reliable and valid. Bye-bye.